Hey, let's greet each other properly. Good morning. This is Mr. Aynesworth here in Temecula, California, Great Oak High School in financial algebra. And we're going to get into a cool lesson review, actually, of revenue and expense functions and how to use DESMOS to calculate all kinds of things, such as the maximum revenue and break-even points and the roots of the revenue function and what intervals of the function or what intervals is the company profiting versus losing money. So we're going to go through all of that in a fictitious or hypothetical situation here. Okay, so let's get right into it. You're going to need Desmos here, so go off to the side. Notice I'm split screening here. I got Desmos on the right. Make sure you title your lesson. So go ahead and sign in and log into your Desmos account. Title it with the same title that I have up here on the screen. And that way we can work together and you can save your work. All right, and so let's get right into it. We've got to go through this entire activity here together. All right, but let me just zoom on to the first portion of the problem here. So here we got Bean Industries here. You know, Bean's one of those professionals, really successful industries in society here, and they manufacture cell phone accessories. You know, Bean, he knows what's going on. He's got it going. Okay. So what's going on? A particular item in the product line costs $3 to manufacture. Right there, we know the unit cost. Okay, so the unit cost, all right, of this particular item is $3 per accessory. Okay, we don't know exactly what it is, but it's a cell phone accessory. All right, so per item. That's called the unit cost. All right, the fixed costs are right here, $3,000, and right there we can write the expense function in terms of the demand Q. All right, they also give us the demand function, so that's kind of nice. All right, so the demand function in terms of the price is given right here. Q, the quantity, is determined by the price, where it's equal to negative 1100 times price plus 9,000 more, and so on, where Q is the quantity that the public will demand. That's why they call this the demand function, and it's in terms of the price. So what we need to do is write the expense function in terms of the price. And we also need to write the revenue function in terms of the price, so we can graph them and figure out the break-even points. We can figure out their intervals of where the company's profiting versus losing. We can figure out all kinds of things. So let's get right into it and maximize our time. No pun intended. Okay, here we go. So what we want to do is write the expense function first. So the expense function is always your variable expenses plus your fixed expenses in general. All right, and so E stands for expense, total expense function. And the variable expense is always unit cost times quantity. So we take the unit cost of $3 and times it by the quantity plus your fixed expenses, which it says right here, fixed expenses, obviously $3,000. So we have to add $3,000 to this. Now we need this function in terms of the price, because we cannot graph this on the graph here where the horizontal axis is going to stand for price. Okay, we want all functions in terms of P, okay, not quantity. And then the vertical axis is going to be in terms of dollars, and we're going to be able to graph the revenue function, and we're also going to graph the expense function in terms of dollars. So the price is in terms of dollars on the horizontal, so P on the horizontal, and we got dollars, which is going to represent revenue and expenses on the vertical. We've done this before, so you should know what I'm talking about. So this function here, the expenses is 3 times Q, the demand, plus 3,000. This is not in terms of P. We want it in terms of P, the price. So what we're going to do is we're going to take our demand function, which we know Q is equal to negative 1100 P plus 9,000. We're going to take this and substitute it in for Q. All right, just do a little simple algebraic substitution step. So the expenses is going to be 3 times all of Q plus 3,000 more. And then we're going to bring in what Q is equal to, which is right here, negative 1100 times P plus 9,000. So we do a little substitution. All right, we substitute the demand function into the expense function. Okay, and then we simplify. All right, so let's do this. And so we got 3, let me see, we got to distribute twice, right? Got to distribute here and then collect like terms. You know, this basic algebra 1 stuff. Okay, so 3 times negative 1100 is negative 3300 times P. 3 times 9,000 is 27,000. All right, 3 times 9 is 27. That's how I got that. And then I have to add 3,000 more and then collect like terms. We got negative 3,300 P. And then this stuff right here, this mumbo jumbo, as they say, this extra stuff right here, 27,000 plus 3,000. Well, hopefully you can do that in your head, and that's 30,000 total. So now we have the expense function in terms of P. So this is called the expense function. All right, in terms of P, all right, which is called the price. Okay, so that is our first main graph, and we're going to graph this. We're going to take this function down here, all right, and we're going to graph it here. All right, using DESMOS, and now you guys are going to sketch it on your paper after using DESMOS. All right, I'm techie here, so I'm going to do something else, but you guys are going to be sketching your graph from DESMOS right here. It's not going to be that hard because DESMOS gives you all the critical points, like the maximums, the roots, okay, and all that kind of stuff. So it's going to be a lot easier than you think. So now what we need to do is get the revenue function. Now the revenue in general, let's write the main concept up here at the very top. The revenue in general is always equal to price times quantity. Price times quantity. Okay. Quantity. Always. All right. P times Q. So revenue R. Okay, so R for revenue is going to be equal to P times Q. Now, Q stands for quantity, and what we're going to do is we're going to take the demand function and substitute it in here to get it in terms of P, because we want it in terms of, again, P, okay, not Q, all right, but in terms of P. So what I have to do is I have to take the demand function, all right, and substitute it in again. So I have to do two substitutions. I had to substitute in the expense function to get it in terms of P. I had to substitute it into the revenue function to get it in terms of P. I'm using two different substitutions to get both functions in terms of P. And notice that I keep on saying the same thing because it's that important. So revenue R is equal to P times, all right, all of Q. Now Q, once again, look right here. I did it earlier. It's the negative 1100 times P plus 9,000. So you take the demand function, which we call Q here, okay? We substitute it in. It's called a substitution step from Algebra 1. Okay, again, we're just using Algebra 1 basics. And we distribute through, which you learned in your algebra classes. Okay, so I'm not doing anything too fancy here. So the revenue is equal to P times negative 1100P. P times P is P squared, so I get a negative 1100. Let me write that better. So negative 1100 P squared. And then when you distribute twice, you get P times 9,000, so that's obviously 9,000 P. Now notice we have a square term here, and that means that you have a quadratic, okay? Anytime you have a squared term, you have a quadratic function. It's second degree because of the square, and that means you have what's called a parabola, all right? Now the lead coefficient is negative, okay? It's negative, all right? So the parabola opens down, not up, which means that this parabola has a maximum, which is why we can find the maximum revenue at any particular cost. Okay, so now that we have our two functions in terms of price, we are going to bring them into DESMOS here and graph these functions. So let's graph the first function. So here we go. We're going to type it in. And I'm going to type it in terms of y and x here. Excuse me. So I'm going to do a little variable switch. My first function here, expense function, I'm going to write it as y equals negative 3,300x plus 30,000. All right, just type it in. So we have y equals, all right, negative 3,300. All right, times not p but x. We're going to do a little variable switch. All right, plus 30,000. And then I'll adjust the settings in so we can actually see the function here in a minute. And then my next function, all right, is your quadratic function. So again, instead of revenue, I'm going to call that y for right now. The y value is going to be equal to negative 1100, all right, times not p squared, but x squared. So x is going to be price in this case. So x squared, and then plus 9,000x. So plus 9,000 times x. And then what we're going to have to do is adjust the scale so we can actually see the graphs. All right, and then we will be able to plot this on our graph. Okay, so I'm going to maximize this so we can see this better here and show you guys how to adjust it. Now, notice that the y-intercept up here is 30,000. Okay, the first function is linear. The negative 3,300 stands for the slope, and the 30,000 represents your y-intercept. And the y-intercept right now is, it doesn't go any higher than 6. So we got a problem here. So we have to adjust the settings. And so it makes sense to go from 0 to something because the price can't be negative. So set the price to 0, and that's called your x minimum. And then your y, or your x max. We really don't know what it is, so let's just set it to 30 right now. We can change that. It kind of looks like that's way too big. So let's set it to 10. So let's go back to 10, okay? And we'll change that if we need to. Step 1 is fine, which means you can't buy ones on the x-axis or the price axis. And then the revenue can't go negative, okay, in this situation. So we're going to go from 0 to something huge here. And usually what I do is I just type in 10 and I keep adding zeros until I can see the graph. Okay, so that's too big. So 100,000 is too big. So we're going to go maybe, let's try 50,000 instead. So I'm going to change this and try 50,000 and see if that's fine. Okay, and even that's kind of big. So maybe 40,000. So I'm going to decrease it. So notice this little trial and error here. Okay, that's pretty good. So now I can see my graph. I can see both the expense function and the revenue function. So the one in blue is the line is my expense function, and then the one in green is my parabola. That's my revenue function. And so what we want to do is take a look at all the different critical points right through here. So I just want to check something here. Okay, so what we want to do is take a look at all the different critical points on the function. And there we go. All right, so let's start clicking on some points. When you click on the function, all of the critical points will come up. Like where the parabola, the revenue function, meets the x-axis, we call those the roots. They're the x-intercepts of the roots of the function, and they will have meaning, and we'll interpret those here in a minute. All right, the maximum point at the top of the revenue curve, that's gives you the maximum. We'll talk about that. The break-even points are where the revenue equals the expenses, and that's where you see the intersection points here. So click on those. All right, and these are the points that we could use to sketch the graph. So you can plot 0, 0. You can plot 8.18, roughly 8.2, a little bit bigger than 8. And you can go up here, and you got to go right 4, a little more than 4, then up 18,409 roughly. And you can take this and you can graph it over here, okay? Because I already have the correct scaling for you. So you can plot the points here as we talk about it. I'm going to clip it in here, but you sketch it on your paper here, okay? And again, you just plot. Like, for example, you know it has to go through the origin. You know it has to go through this point 8 point something right here. So 8.1 or 8.2. The line has to go through roughly 9.1 and all the way up here at the y-intercept. So you know the line has to intersect up here and then down here at 9.1, which is right over here. So you can draw the line. So get out a ruler, and obviously draw a line. So if it was me, so we'd have something like this here. Okay, so you draw your line. It's not that hard. Okay, so you got your demand curve right here, and then you've got your parabola. Parabola's a little bit more challenging to draw. You need to know the max. So you click on your function and you go. So the max is at 4.1, up 18,400. So 4.1, and then you go up to 18,000, 400, So 18,000, so that's 15, 16, 17, 18, so roughly right here. And then you can draw your curve. So okay, whoops, yeah, something like that. Not the greatest sketch, but you just need a sketch. And then right here you got your first break even point, you got your second break even point, so you can sketch it from there. What I'm going to do is I'm going to clip it in here and then annotate it. So let's go back to the graph here and let's do some analysis. Okay, so we have a couple break even points. Okay, so one here at this point, and then we've got a maximum there. We've got another break even point here, and we've got a root here of the revenue function. All right, and what we want to do is we want to bring that in and annotate it. And we want to answer all these questions, all right, off to the side, okay? We've got to answer all of these on this graph. So let me see, let me change the scale here, so give me a second. Okay, so in part C here, what we want to do is we want to figure out what price yields the maximum revenue, and that always occurs at the vertex. Okay, so let's make a little note. This always occurs, okay, at the vertex of the revenue curve. Okay, and this revenue curve goes downward or opens downward, and so this curve has a maximum at 4.09, or roughly when the price is set at $4.09, we get a maximum revenue of $18,409 roughly and 9 cents. All right, so we can see the maximum right through here. We can see the break-even points here. There are two of them because when revenue and expenses are equal, that means when they intersect graphically, that's how you tell when revenue meets expenses, which indicates we have two break-even points right there. And then we can also see the roots of the revenue function here where the revenue function in green meets the x-axis. So let's take all of this here. Let me expand it just so you can see things better here. It's a little bit too big, so let me just change the scale just a tad bit. All right, there we go. We can see things better. So we can see the roots. Click on the roots where the revenue function meets the x-axis. At the very top, click on the vertex, which gives you your maximum. And then click on the leftmost break-even point and the rightmost break-even point. And let's take this graph right here and let's bring it in. You guys can sketch it, obviously. But I'm going to clip it in because I'm digital here. And then bring it in, we can annotate our graph. Okay? Annotate meaning we can write down everything that's important. Okay, so let's do that. Alright, so let me grab mine, let's bring it in. And let's kind of play around with the ideas here. Alright, so here we go, let's get started. Okay, so we have this function here with this graph. And then let's go through all the different aspects of it. Okay, so we want to figure out the price that yields the maximum revenue. So just take a look at the top here in the directions. We got to answer all these questions here. So let's annotate it first, and then we'll go off to the right and do a little bit deeper analysis here into what's going on. Okay, so remember one thing. Let's we've got an expense function here in blue. That's our line. That's our expense function. It's linear, which simply means it's a line, okay? It's a line. Okay, the revenue function is second degree, okay? So it's a revenue function, and this is the amount of income coming into the company, okay, after they're selling product. They obviously get money. We call that revenue. Now the horizontal axis is the price, so let me indicate that here. So P is on the horizontal, we got dollars or expense on the vertical, so dollars up here, and it's going to either represent the revenue or the expense, depending on what function we're looking at. Okay, either one, but it's going to be in terms of dollars. Everything is in terms of dollars. Okay, so now let's label here. So at the max, so we got a max right here. We got the price here, we got the revenue here, because we're on the revenue curve. Okay, so let's detail that out. So, and that's interpret. Okay, so this point right here, so it tells me that if the price is set to $4.09, all right, the revenue R is going to be $18,409, all right, and 9 cents. Okay, all right, in terms of dollars. That's what the max gives. This is max revenue. Okay, max revenue. So if the price is set either below that number, below $4.09, or above that, you're not going to have this much revenue. You're going to have less. Okay, so that number right there, that price, is important. Every company tries to find that price to maximize the revenue, to maximize the profit. Okay, next thing we know is we have some break-even points where revenue meets expenses. We have two of them, one at A and then one here at B, and these are called break-even points. Okay, so let's make a little note of that. Break-even point, and that's where revenue meets expenses. Revenue, all right, is equal to expenses. You're not making money, you're not losing money. Okay, so that's why they call it break-even. It's kind of like in personal finance. If my wife and I are bringing in $10,000 every month, but we spend $10,000, that means we break even. All right, we can't save any money because we're spending as much as we're making, which is not a good thing. We shouldn't do that. We should be spending less than we're making so we can always save. All right, so break even means revenue meets expenses or equals expenses, and we want to detail that out. So this right here, if the price is set at $3.60, so the first one here, if the price is set at $3.60, and notice I'm rounding, all right, the revenue, all right, obtained will be right here, $18,138. That's break-even price. Okay, so $18,138, and looks like 6 cents. All right, that's your first break-even price. This happens twice in this situation, so once at A and then once at B. Again, this is price and this is revenue. All right, here, so the second break-even price on the right here tells me that if the price is set at $7, all right, and 59 cents, all right, then the revenue and the expense will be the same, and it will be a lot lower in this case, which would be $4,961, and it looks like 94 cents. And the reason why it's lower is because when you set the price too high, there's little demand, and there's little demand, not many people will buy the item, whatever it may be. And then if that's the case, you're not going to make much money. All right, so you got to figure out the magical price to maximize the profit, and it's always between the break-even points, somewhere in there, so the company's profitable and not losing money. Okay, so what else do we know? We know also the roots of the situation here too. The roots of the what's called the revenue function here. A root, all right, is an x-intercept. Okay, that's visually how you find it. The root of a function is the x-intercept of the graph. Okay, so we have one, we'll call this R1 right here, and we have another one right here, we'll call that R2, root 2, second root. And what do they mean? How do they interpret that? So we'll write that down. Well, we might as well just interpret it now because we're kind of there. So off to the right, analysis of the roots. Let's do that right now. I'm kind of going out of order, but that's okay. All right, so the first root, 0, 0. Let's talk about that one. So 0, 0, R1. All right, what that tells me, remember this is P, R. Okay, it's always P, R. Price on the horizontal, and then you got dollars of revenue on the vertical. So here, if you set the price to $0, all right, that tells me that the revenue earned is $0. Okay, because if you just use your common sense here, that if you don't charge the public anything, then you're not going to make anything. All right, you're not making money. Okay, not making money, which is not a good thing. Second root, if you price it at $8.18, okay, this is the second root. So let's just zoom in here. So if you set the price too high and you set it at $8.18, all right, you're still not going to make money either. The revenue is 0 there, all right, because it's too high, there's no demand. Okay, so if the price is set too high, or here the price is set too high, price is too high. Too high. There's no demand for it. No demand, and because there's no demand, they don't sell anything, and that means R is going to be equal to 0. They're not going to make any money. Not making money here either. Okay, and so that's the interpretation of the roots. You don't want to set it to 0. That's no good. You don't want to set it too high. That's no good. It's not good for the public, and it's not good for you in terms of if you're managing the company. Okay, and there's more to it here. So before we answer and do some interval analysis, so let's just take a look at the graph, and then before we do some more work here. So let's take a look at the break-even points. All right, so let's highlight a couple things. So put your pencil at A and then go straight down. Okay, now this price, okay, is $3.60. So $3.60. This will give us your first interval. Okay, so from 0 to $3.60 is your first interval. Something happens between 0 and $3.60. Again, this is the price. All right, and what we want to do now is we want to talk about whether the company's making money or not. All right, so before the break-even point and between the break-even points, something occurs. So find your second break-even point at B. That's at $8.18 right there. That gives you your second interval. We'll call that I2. I1 is your first interval. I2 is your second interval. And then beyond the second break-even point, all the way to the right, that's your third interval. Okay, we'll call that I3. These are called intervals. Intervals. All right, when is a company making money versus losing money? All right, so to do that, to analyze that, what we do is we pick a price in the interval, all right, between 0 and $3.60, and we figure out which one's greater, revenue or break even. So I'm going to sidetrack here and go to DESMOS here and put it side by side and show you how to analyze it. All right, so this is kind of a cool thing here. Okay, so when you analyze, yeah, that'd be good. What you do is you pick a price in the interval, and then you take a look at the actual values of the revenue versus expense, and you figure out which one's greater, and then I'll tell you whether the company's making money or losing money. So now let's zoom in and let's focus in on the first interval here. And that is between 0 and $3.60. All right, and so we can answer these questions on the right. In fact, let's take a look at here. Sorry, getting a little crazy here. All right, so in our first interval here, it says, what is the price at the first break-even point? Well, the first break-even point is at $3.60. Okay, so let's put that in there. It says state the first interval from 0 to the left of this break-even point. So 0 less than the price, less than $3.60. There's your interval. All right, where the price, and this is P's price now, is between 0 and $3.60. That's what's called a compound inequality, and it simply means that the price ranges from 0 to $3.60. All right, in that first interval. Use a compound inequality to do that. And it asks you to determine whether the revenue or the expense, or to compare the revenue and expense in that interval. So what you do is you pick a price between 0 and $3.60. Like 2, for example. 2 is between those two numbers. So I'm asking you here in this question is like, what is the revenue if the price is at $2? What is the expense? Okay, when you set the price to $2, and you figure those two numbers out and you compare, and then you know. Okay, so there's no guessing, there's only knowing. All right, so let's go back to here, and let's go and let's set the price to $2 and let's analyze it. So what you do is you set the price to 2. Now the price is on the x-axis, so what I'm going to do is I'm going to type in x equals 2. And you'll notice that a vertical line appears. Okay, x equals 2 is a vertical line, which represents the price equal to 2. And it intersects the expense function here on the blue curve, and then the revenue function down here. And notice that on the expense function, if the price is set to 2, then the expenses are $23,400, and then the revenue is 13,600. So the expenses are much higher, almost $10,000 higher than the revenue. And if you're spending more than you're making, you're losing money. All right. So what we want to do is kind of graph that in on your paper here. So let's just graph that vertical line at 2. So find 2, which is right here, and go straight up. And this point right here, and this point right here are the values that you see on the right-hand side of my screen in DESMOS. Okay, so the first one here, this one is at 2, 23,400. Okay, and the one on the bottom is 2, 16,300. All right, and now we can answer the question. Okay, so let's go back here to the question. It says, what's the revenue if the price is set at $2? Well, it is 16,300. The expenses are much higher, 23,400. Okay, obviously expenses are greater than the revenue, which means we're spending more than we're making. All right, and so in this case, we're losing money here. This is a bad thing. So we're losing money. Not good, okay? Not good. This is a bad situation, okay? So you don't want to set the price between 0 and $3.60 because the company's going to be losing money. All right, so if you were the financial analyst in the company, if you were Bean, okay, you would say, if you were the bean counter, as they say, you would say, hey, this is no good, guys. This is no good. Do not set the price here. It's too low. It's too low, man. So you got to go a little bit higher. All right. So where does the company profit? Well, I don't know. I do know, but let's analyze it. Let's pick a price between $3.60 and $8.18. Well, over here it says in the second interval analysis, it says what's the price of the break-even point? Okay, so we know that. Okay, the first one is $3.60. The second one, if you look on the graph, is $8.18. Let me see. No, it's not $18.08. I miswrote. Oh, you know, I just found a little mistake. You guys got to fix your notes because I'm not going to rerun this video here. The first break-even point, I misread my DESMOS here, is $7.59. Holy cow. Okay. I can't believe that. I was looking at the root. This is the root right here. Okay. I misread it. So go down. Let's fix right here. This is not 8.18. This is 7.59. $7.59. So $7.59. That's the price at the second break-even point. Okay. Misread my DESMOS graph. Come on, Aynesworth. This is the root here, not the break-even point. So this is the root. My break-even point is at B. I even wrote it down, $7.59. Okay, this is my second break-even point. I hate it when I do silly mistakes like that. Okay, so anyways, fix your graph here. Okay, so let's go back. All right, and let's do this correctly here. So the second break-even point is when the price is at $7.59. So my second interval, I have to go from $3.60 to $7.59. So it says state the second interval. Here we go. So $3.60 is less than P, which is less than $7.59. So just use a simple compound inequality to state that the price has to be between those two numbers. That's how you write it, okay? Minimum to maximum, all right? Min, max. That's all you do. Now it says, what will the revenue be when the price is at a 5? Now notice 5 is between those two numbers, right? So I just picked a number between there. I could have picked 5 or 6. I could have picked 550. Pick any number between these two values, okay? But I picked 5, all right, just to have you guys play around with it. So let's go back here, and then let's figure this out. So I find 5 on the x-axis, go straight up, and you draw a vertical line, and it obviously intersects the two curves there. Intersects the revenue curve here, and then the expense curve here. Okay, so now we got to find those values. All right, so that's easy to do. All right, so here you type in x equals 5. Okay, and it intersects the two curves at these 2 points. All right, so at the revenue curve here at 5, 17,500, and then on the expense curve 5, 13,500. So you can see that the revenue we're bringing in is wow, look at that. It's $4,000 higher on the revenue versus expense. So here we're making money, okay? We're profiting here. Okay, so if we annotate our graph, okay, this first one is at 5 comma 17,500. All right, the next one, 5 comma, looks like 13,500. Making money here. This is a good thing. Okay, so let's go back to our graph. I mean our lesson here. So what would the revenue be at if the price is at $5? Well, as I just said, it's 17,500, and the expense, okay, is 13,500. At that point, we just gained, that's an additional $4,000 there, profit, okay? So compare the two. Well, okay, revenue is greater than expenses. All right, and that means you are making money. Okay, that means profiting. And that's a good thing. This is good. Okay, be happy on this one. All right, so you want to be between the break-even points. So in this region, it's good. So if I just color code something here, just color code this lesson here. So in here, anywhere in this region in interval 1, that's bad. Okay, this is a bad place to be in because you're losing money. If you're between the break-even points, okay, so anywhere in here, if you're in between the break-even points in this middle interval right here, this is a good thing. Okay, good thing, because you're making money. This is profitable. Okay, this is profitable. Okay, and then what happens after in the third interval? Well, the price at the second break-even point is $7.59. Okay, got it right this time. All right, and state the interval from infinity, so the price is just simply greater than $7.59. So when you're greater than $7.59, anything to the right, all right, the price is going to be too high. So but just to play with it, let's figure out what's revenue, what's expense when you price set it at $8. Okay, well, it's easy to figure out. So you just type in x equals 8. All right, and then voila, it gives you some values. So let's zoom in over here and let's click on it. So here's the expense function. We got revenue here in green. We got expense in blue. Okay, so the expenses are 3,600. The revenue coming in at 1,600. We're 2,000 negative. Okay, which means we're in the hole. Okay, we're losing money because we're spending more than we're making. All right, so what you do is you go over here to the graph. All right, and you find 8 and you draw a vertical line. The same approach. Okay, and so the expenses right here, it says 8 comma 3,600. That's an expense. And then right here, this one here on the revenue curve, that's going to be 8 comma 1,600. All right, that's revenue. That means that's the money coming in, right? Because on the green curve, the parabola is the revenue. On the blue line, all right, that's the expense. And obviously $3,600 going out on expenses is 2,000 more than 1,600. So we're losing out here. We're losing money in this situation, okay? So if you set the price too high, this is too high, all right, the revenue is going to be big. All right, so the revenue, as I said, the revenue is going to be small. So 1,600, you're making 1,600, but you're spending 3,600. Again, this is expense, and this is not good, okay? You're spending more than you're making, okay? The expenses are greater than the revenue. All right, this is a bad situation. All right, and so you're not making money, you're losing money, okay? You're losing money here. You're going to be negative 2,000 here. You're going to be in the hole. And this is a bad situation. You don't want to be in the third interval. So when you run a business, you want to price things so you stay between the break-even points so you're profiting and not losing. Okay? And that is important. And that's how you really analyze the situation. Okay? So I went over how to find the maximum by looking at the vertex. We determine the price that yields the maximum. We determined the price and the revenues at the break-even points. We found the roots and interpreted them. We also found the intervals in respect to the price where the company profits and loses money. Okay, and that, my friends, is a big summary of sections 4 and 5, and this will get you prepared for 6, 7, and 8. So fun times. Hopefully that helped you out. Hopefully using DESMOS here, interacting with DESMOS really helped you out. Make sure you press the save button because you submit all your work here and that you produce in class. This actually just validates all your work because it's very difficult to do all these things without a nice tool like this. So submit your DESMOS in as a hyperlink in Canvas here. Take a PDF of this and submit this in Canvas as well. And make sure your work is fully annotated. It has to look like this, okay? And then, oh, I forgot one little region here. Just to make it kind of cool looking, all right? The yellow region is we're losing money. The blue region between the break-even points is the good region, the profitable region. And then when you go beyond the right breaking point in this green region, that's bad too, okay? So you don't want to be over there. So you don't want to be in interval 3. You do not want to be in interval 1. You want to be in somewhere in interval 3. You want to set the price between the two break-even points. All right. So the company's profitable, man. Okay. You want to make money. All right. At least Bean would want to make money, right, Bean? Okay, Bean. All right. I see you guys in class. This is Aynesworth. I'm out of here. Bye-bye.